Okay, so now let's talk about what happens when we take a piece of glass and we change the shape of it. We create a lens. There are two types of lenses. There's a converging lens, which is called a convex lens. And there's a diverging lens, which is called a concave lens. So let's concentrate on the converging lens first. First of all, the line that goes through the center of the lens is called the principal axis. So imagine that we have some light rays that are over here on the left-hand side. And they enter this piece of glass. Because it's thicker in the middle, it's going to bend. And it's going to be converged onto, so it's going to go to the center and then it's going to bend and it's going to converge onto a common point called the focal point. The distance from the center of the lens to the focal point is called the focal length. And for any type of lens, like a convex lens or magnifying glass that converges light, the focal length will always be a positive number to denote that it converges light. A diverging lens, on the other hand, is a little different. Here's its principal axis. So let's say it has a focal length here. If light was coming in from the right side into the left, or if it was going from left to right, the focal point would be here. The focal point would be on either side of these, right? Let's say it's 10 centimeters. But what's going to happen is when light goes through this, it's going to hit the center and then it's going to diverge away from a common point. And that happens to be the focal point on the other side. So it hits the center and it's going to diverge away from the focal point. So notice that these rays that are refracted out will never ever intersect, which means that the images that form are not images that can be projected. Whereas with a converging lens, because the rays of light converge onto a point, you could put a piece of paper there and you would see those light rays. But you can't do that here. They do, the projections of them do converge on the focal point behind the lens. So to denote that this is a diverging lens and that the rays are diverging away from that focal point, the focal length is going to be negative for anything that diverges light. So there are a couple of equations that we use. First of all, usually when we have a lens, we have some kind of object and we have a focal point that can be on either side. And so we have a distance to the center of the lens called the object distance. And then an image is going to form somewhere. So we have the distance to the image, and then we have the focal length. And the relationship between these mathematically is the lens maker's equation, which is 1 over f equals 1 over di plus 1 over dou. Now, we can also talk about the magnification of the image. Is the image bigger or is it smaller than the object? So one way to find the magnification is just to take the ratio of the image height to the image to the height of the object. Or we can take negative distance to the image divided by distance to the object. So let's talk about converging lenses in our next video.